Welcome back to Series on Catalyst University. My name is Kevin Tokoph. Please make sure to like this video and subscribe to the channel for future videos and notifications. Alright, in this video, as I promised, we would do another ratio test example. So here's my problem right here. I have a series from n equals 1 to infinity of negative 10 to the n power over 4 to the 2n plus 1 times n plus 1. All right, and remember our criteria. Our limit L, if it's less than 1, our series absolutely converges. If L is greater than 1, the series diverges. And if it's equal to 1, it's inconclusive and we'll need to use another test. All right, let's figure out what our a sub n is for this series. Well, a sub n, we're just going to have negative 10 to the n power over 4 to the 2n plus 1 times n plus 1. All right, simple enough. Now for our a sub n plus 1. What is a sub n plus 1? Well, everywhere I see an n, I need to add a plus 1. So for negative 10 to the n, it'll be negative 10 to the n plus 1, okay? And then in the denominator, I have to be careful here. Here I have 4 to the 2n plus 1, so this entire n I need to plug in an n plus 1. So this will be 4 to the 2 times n plus 1 and then plus 1. And then this n plus 1 just becomes n plus 2. All right? Now if I simplify this, I still have negative 10 to the n plus 1. I still have this n plus 2 here, but now when I distribute this 2 to the n plus 1, I'll initially get 2n plus 2, but then I've got an extra plus 1, so it'll be 4 to the 2n plus 3. All right. Now, the ratio test says my limit is equal to L. It's the limit as n goes to infinity of a sub n plus 1 divided by a sub n. So I just plug in what I just found. So a sub n plus 1 is negative 10 to the n plus 1 over 4 to the 2n plus 3 times n plus 2 divided by a sub n, which is negative 10 to the n divided by 4 to the 2n plus 1 over n plus 1. All right? Now, I pretty much just need to simplify this. And the main thing to first simplify is really the numerator. This is the main part. I can break up this n plus 1 as negative 10 to the n times negative 10 to the 1, or the first power. And then the 4 to the 2n plus 3, I can break that up also. 4 to the 2n times 4 to the third, and then n plus 2. All right? Now, not as much to do in the denominator, but we got a little bit of work. This negative 10 to the n doesn't change. I still have n plus 1 there, but notice the 4 to the 2n plus 1, I can break that up also and get 4 to the 2n times 4. All right? Now, a bunch of stuff cancels, which is really nice about the ratio test. The negative 10 to the n cancels, okay, so that's why it's gone over here. Also notice the 4 to the 2n, that cancels, all right? And then also notice one factor of 4 cancels here because 4 to the third divided by 4 is 4 squared. All right. So now in the numerator I have negative 10 over 4 squared times n plus 2 over 1 over n plus 1. Now what I'm going to do is I'm going to turn it into a product. Let's get rid of this quotient. And I could do that technically in one of the previous steps. So now I'm going to change it. Limit as n goes to infinity. I've still got the negative 10 over 4 squared, but now I'm going to move this n plus 1 up here in the numerator, because if I'm dividing by something in the denominator, it becomes a product in the numerator, n plus 1 over n plus 2. All right? And notice, again, I still have all these absolute value signs here. That's very important for the ratio test. All right, so got the same thing down here. Limit as n goes to infinity of negative 10 over 4 squared times n plus 1 over n plus 2. Now, because I'm taking the absolute value of negative 10 and 4 squared, now for the 4 squared it really doesn't matter, but I'm taking the absolute value of all these constants, which I can pull out. There's no n in either of these number terms, so I can pull them out in front of the limit, and when I pull the 4 squared out, nothing happens. I'm just going to say it's 16. But when I pull the negative 10 out, it becomes positive since I took its absolute value. So I have 10 over 16 times the rest of the limit. So the limit as n goes to infinity of n plus 1 over n plus 2. Now, you can evaluate this limit any way you want. It's technically indeterminate form, infinity over infinity, but it's a pretty easy limit to evaluate. You could use L'Hopital's rule. You're going to get 1 over 1. Or you could just recognize that the coefficients of both of these n's are both 1, and since their powers are the same, the limit is 1. All right? So, therefore, this whole limit is just 1, and so the overall limit L is just 10 over 16. All right. Now, 10 over 16 is less than 1, right? So my limit is less than 1. So, by the ratio test, this original series is absolutely convergent, or it converges absolutely. You can put it either way. All right? So that's one example of the ratio test. All right? Hopefully this helped you gain a better understanding of it. So please make sure to like this video and subscribe to the channel for future videos and notifications. Thank you very much for watching this.